So the second part of today's lesson is being able to calculate arc length in radians. So you will have done arc length at GCSE higher. So let's have a refresher of how we would do it in GCSE. So if I knew that this was an angle theta and I wanted to work out the arc length L, to work out L, I would do theta over 360, because it's that fraction of 360, times by, and I just realised I've not put R there, times by the whole circumference, because whatever this fraction is of 360 degrees will be the same fraction of L of the circumference. So it would be 2 pi R. Might be pi D, but let's just keep it in terms of radians rather than worrying about diameter at the moment. So that would be if we were doing it in degrees. So if we were doing it in radians, it would still be the same initially. It's still theta. It's just theta over 2 pi is our fraction rather than theta over 360. Times by, again, the whole circumference, which is 2 pi R. Now, what's nice here is that I'm dividing by 2 pi and multiplying by 2 pi. So they cancel out. So therefore, L is actually just theta times by the radius. This only works for radians because we are talking in the same numerical system, the same sort of base really. That's a different base to this. This is the base of radians, this is the base of degrees. Here we're talking about the same base, so they can cancel. Do not use that with degrees, it will not work. It only works for radians. You do need to remember that is not given to you. So therefore it is key for you. So we're going to do quite a few examples to use that, because it is quite a simple concept, so we can use it in a variety of different ways. So example number 1 says find the length of the arc of a circle of radius to 5.2, not 2.5, can't remember numbers, given that the arc subtends an angle of 0.8 radians. So to subtend, you'll recognise that language hopefully from circle theorem. The arc subtends an angle, that means it is joined up from the centre by 2 radii of an angle 0.8. So L is quite simply theta 0.8 multiplied by the radius 5.2. I would say write down theta R when you are doing it, because you're not given that calculation, that formula. So if you write the formula down wrong, you might get some substitution marks. I mean, I expect for something as simple as this you wouldn't, but it doesn't say to give it as a decimal or a fraction, so you could give it as 104 over 25, but because it's a simple decimal, 4.16 centimetres is that arc length. Okay, so it is really straightforward in this basic term. Example number 2. An arc AB of a circle with radius 7 centimetres and centre O has a length 2.45 centimetres. I always draw these out. So it has radius 7 centimetres and has the arc length, I don't know why I've drawn it so big. Arc length 2.45 centimetres. Find the angle AOB subtended by the arc at the centre of the circle. I think it is good to sketch because it just gives you a visual of what information you have. I did do my angle really massive, but obviously that's smaller than the radius, so it must be quite a small angle. But you know what, if you've drawn it wrong, it doesn't actually matter. You know, as long as you can calculate it, it's just a visual representation. So L equals theta R. So 2.45 is equal to theta R, theta 7, so we know what R is. So therefore theta must be 2.45 over 7. So theta, now you can put 7/20 rads, or if you want it as a decimal, 0.35 radians. Example number 3. We've got a few examples because I sort of start to get a bit more problem solving. An arc AB of a circle with centre O and radius R subtends an angle of theta radians at the centre 0. The perimeter of the sector AOB is P centimetres. Express R in terms of P and theta. So, I know that the perimeter must be the arc length plus 2 lots of R. Okay? Well, I know that the arc length is theta R plus 2R. And that's it. So that's the perimeter. It's express R in terms of P and theta. So I've just got P and R and theta in. So I haven't got my third variable, which I don't, well, technically my third variable that's not in terms of the ones that I want. So I've got R in both of these. I need to make R the subject. So I need to factorise this out. So therefore R is equal to P over theta plus 2. Okay, so relatively straightforward, which is really nice. It looked like a horrible question, but as long as you know that they're talking about the perimeter of the whole sector is these 3, and you know that L is theta R, and these are not too challenging type questions. Okay, so we've got 2 more examples, which are slightly more complex. So I'm going to sketch this diagram out for you. Badly, I would say, is probably, but A, B. So this is the curved part called C. And this bit here is 2.4 metres. Okay, so the border of a garden pond consists of a straight edge AB of length 2.4 metres and a curved part C as shown in the diagram. The curved part is an arc of a circle with centre O and radius 2 metres. Find the length of C. So what we have missing is this theta here. However, what we have here quite nicely is a triangle. So I can work out this value, x, here. So I've got 3 sides I need to work out an angle. So I'm going to use the cosine rule. So I know some of you remember the rearranged formula off by heart because you'd rather do that than rearrange. I just remember, I do know the other one, but I prefer to substitute it in here and rearrange. I think you're more likely to get it right because I do sometimes misremember the other one because I find that rearranging is easier than memory. If you remember it, you can go straight to the rearranged version, which would be cos A equals B squared plus C squared minus A squared divided by 2BC. but you don't have to remember that version. So if this is my angle, this must be my A and these my B and my C in this context. And obviously that would be cos of x. So 2.4 squared is equal to 2 squared plus 2 squared minus 2 times 2 times 2 cos x. So I'm going to change to black just because actually it's a bit easier to read than pink. So 5.76 is equal to 2 squared is 4, so we've got 8 minus 8 cos x. So just going to rearrange to get cos x on its own. So cos x is equal to, it's going to be 5.76, subtract 8, and then divided by negative 8, which gives us 7 over 25. Now, you technically could work this out in degrees, but why would you? Because arc length is theta L, so, and when it's in radians, so you shouldn't. So in, hello, so cat's just come in. So arc cos or inverse cos of 7 over 25. X is 1.287. Now I'm going to put dot 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 because I will use all of that value when I'm working out my theta. So I know that theta is 2 pi minus x. Because obviously they add up to 2 pi because it's a full circle. So theta, 2 pi minus my answer. So I'm using answer rather than the rounded value. 4.99618, blah, blah, blah. So C, therefore, which is theta times by the radius, is 4.99 blah 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 times by 2. So answer times by 2, which is 9.99 meters to 3 significant figures. So it doesn't, no, it doesn't give me what it should be. Sorry, I'm trying to stop my cat come on the lap so it doesn't interrupt the video. So slightly harder problem solving question because it involves that GCSE triangle knowledge. It is really important that you do still know those bits of information because they are not given to you, I don't think, because it is just expected knowledge. Okay, final example. 1, 2, 3. That one was 4, so this one's 5. In this circle, so you're just given a circle like this. You should still be following along just because it's not always easy to listen to this point. And sort of retain all the information. So arc AB is equal to 7.86 centimetres. Oh, I just realised I can't do this question because you haven't done area of a sector. So I will leave this in the PowerPoint because I will come back to this next session. Don't try and do it now because you haven't done area of a sector. Area of a sector is what you'll be doing in your next maths lesson with you. So I will come back to this question. But yeah, silly me, not really checking. I was like, yeah, got this really difficult simultaneous equations, problem solving question from the IB, so I'll throw that in there. Forgetting you needed area of a sector. I don't know why. I think I just thought it might be related to perimeter, maybe, and it's some simultaneous equation. I don't know. So sorry about that. Can I make up a question off the spot with perimeter? I might do. I might, in the meantime, make up a perimeter and area of a sector question. I don't want to do it off the top of my head because you might just get some really nasty answers if I did that. So I probably will add one on later now that I've had to think about it. or when I've had to think about it. But for now, that's it. So I apologise you can't do that last question. But that is arc length. It is relatively straightforward, but they will incorporate more challenging things like this. And when we do area of a sector next, some more challenging questions will obviously appear then. So yeah, get yourself practicing.